One, कैसे हो? Everything is okay ना? So in this topic, in this means structure of atom. In this topic, for the write-up of the electronic configuration, 3 points are very important. Which are these 3 points? In that, first one is the above principle, second one is the Hund's rule, and third one is the Pauli's exclusion principle. So out of these 3, we have completed first one. Which one is that? Above principle. Okay. Now it's time to discuss the Hund's rule. So Hund's rule is nothing but the Hund's rule of maximum multiplicity. Maximum multiplicity. So what is the use, how to apply this one, and what is the statement of this Hund's rule? That we will discuss today only. Okay. So in this topic, firstly, in this bit, first statement of the Hund's rule is before going towards the statement, shall we discuss some points which are helpful to understand that statement easily. Now, which is the point? Now see, as we have discussed subshells as well as orbitals. So subshells, as we know that they are named as a SPDF, and orbitals, for each subshell there are the some orbitals are there. For example, if we consider S subshell, there is a possibility of the only one orbitals, which for that one we are drawing only one box. Clear? Now see P. For the P subshell, there are the 3 orbitals. For that one, we are drawing the 3 boxes together. That together we are writing because if we consider first one, it is Px, Py and Pz. If we consider these 3 boxes, we are drawing it together, means they have the same energy. Means when orbitals have the same energy, these are called as a degenerate orbitals. What is that? Degenerate orbitals. Okay, like that, if we consider for the PDF, okay, SPDF, out of that S having only one, so no issue. But for the P, for the D, for the F, there are the multiple orbitals are there. That's why they are having the same energy, so they are called as a degenerate orbitals. Now see, for the P subshell, 3 degenerate orbitals are there. For D, as we know that 5 orbitals are there, so we are drawing here 5 boxes, 1, 2, 3, 4, 5. Means these 5 orbitals having the same energy, means they are degenerate. If we consider for the F, 7 orbitals are there. And for that one, we can draw the 7 boxes, 1, 2, 3, 4, 5, 6, 7. Means these 7 orbitals have the same energy. Okay. यहाँ पे आपको पता चल गया what is means how many orbitals are there for a given subshell and what is meant by that degenerate orbitals. If we consider now, next turn is to understand, that is the pairing. As we know that paired and unpaired, everyone knows that paired means 2 and unpaired means single. Okay. So for that one, what is the use? As we have seen that in the quantum number, spin quantum number, electron having the 2 orientations which are distinguished by the spin quantum number. In that, one is represented by the upward arrow and second one is by the downward arrow. This is the one point. Second point is that each orbital, means each box which we are drawing, that each box is completed or it is completely filled with the 2 electrons, maximum 2 electrons, minimum 1 electron we can fill. So these 2 points are helpful to us. If they are paired, means every time when we are writing the electrons, that should be with the opposite spin. Okay. So after that, all these points, now we are going to start the statement of the Hund's rule. What is the statement? Statement of the Hund's rule is that, listen carefully and please note down the notes also. What is the statement? Statement is that pairing of electron, listen carefully, pairing of electrons takes place, pairing of electrons takes place only when, given orbital, given degenerate we will discuss here. Okay. Given when degenerate orbitals of a given subshell subshell are filled with one electron in each orbital. Okay, so simply listen carefully. Statement of this Hund's rule of maximum multiplicity is that pairing of electron means two electrons can be filled in each orbital. That orbital is, if that orbital is degenerate, at that time each orbital should be filled with the one electron, and after that only pairing is possible. So in this way, pairing of electrons takes place only when degenerate orbitals of a given subshell are filled with the one electron in each. So this is the statement. Hope so you understood that, and after that we will discuss some examples so it is easy to understand. Okay, now this is the statement. What is the statement? Pairing of electrons takes place only when each orbital that is filled with the one electron. Now see, if we consider any one, that is the 3p4. Okay, this is the one example. Next one is that 4s1. Not instead of 1s, we will discuss about the d, that is the 4d7. Okay, so here why I am taking d and not s? Because for the s only one orbital is there, so no issue. But for the d and p, there are the number of orbitals are there, that's why. Now see what is the possibility. P4. For the p orbitals, how many? For p subshell, how many orbitals are there? For p subshell, 3 orbitals are there. So 1, 2, 3. Okay. So how many electrons are there? Previously also we have discussed. This number is n. This is the subshell and this is the number of electrons. So in a third shell, p is the subshell. Okay. Third shell, p subshell and 4 electrons. So for the p subshell, there are the 3 degenerate orbitals. 4 electron can be filled like that. 1, 2, 3, 4. This is the one possibility. Second possibility, what is that? Second possibility is that 1, 2, 3 and 4. Clear? So these are the two possibilities. What is the statement? Statement is that if, means that pairing of electron is possible or it takes place only when degenerate orbitals, these are the degenerate orbitals because they are having the same energy. These degenerate orbitals should be filled with the one electron firstly, means 1, 2, 3. Like that they should be filled firstly, and after that pairing is possible. How many electrons are there? 4. So we have to fill that electrons like that, 1, 2, 3, and fourth one should come again in the first one. Means which of the following is the correct one? This one is the correct method. Clear to everyone? Now see next one. Here 4d7 is there. For d we have to draw 5 degenerate orbitals. 1, 2, 3, 4, 5. What is the possibility? 1, 2, 3, 4, 5, 6 and 7. Means we are going to start with the pairing in each orbital, but it is not the correct method. What is the correct method? Correct method is that if we consider degenerate orbital 1, 2, 3, 4, 5. If we consider this degenerate orbital, each orbital means each box should carry one electron firstly, means 1, 2, 3, 4, 5. After that pairing will start from the beginning. So 6 and 7. So this is the correct method. Hope so you understood that how to fill the electron in the degenerate orbitals. Okay. Now next one, another one example we will discuss. If we consider there are the 2p, 3 electrons are there. So first method is that p orbital means p subshell means there are the 3 orbitals are there. 1, 2, 3. Second method to fill, that is the 1, 2, 3, in that 3 electrons. So 1, 2, 3. This is one possibility. Second possibility is, what is that correct one? Each orbital should be filled with the single electron. So in this way, this is the correct method. Here I have taken 3 examples for the better understanding. Hope so आपको समझ में आ गया होगा what is the Hund's rule and how to apply that Hund's rule. Thank you all of you.